Okay, guys, this video is going to be talking about administrative admin distance. Now, I talk to a lot of engineers, and this is something that a lot of folks have to Google quite frequently. And I'm going to be honest with you, as a network engineer, a lot of times you guys are going to have to remember this off the top of your head. You guys are just going to have to be able to, it's okay to forget one or two of them every now and then, but for the most part, you guys really need to remember your admin distances, especially if you're going to be doing any type of redistribution and things like that. If you're studying for any type of networking exam, this is going to be one of those key bullet points. It's like a cornerstone that they're always going to make you remember. You're going to have to do that. Let me give you a prime example of some of the scenarios that I've run into. So the administrative distance to eBGP, for example. So let's say eBGP is 20. And let's say that the administrative distance to EIGRP, and let's just say this is external. So we're going to get these routes as DEX routes. I'm going to write down all the admin distances in just 1 second. This is going to be 170, right? Now let's say that we have some type of MPLS connection in between some type of layer 3 VPN, going in between R1, 2, and 3. And let's say that we're using EIGRP. So I'm going to put 170 over here. We're using EIGRP over our layer 3 VPN, right? Because essentially we're forming a layer 3 VPN with our service provider that's maybe sitting somewhere in here. We don't really care. And essentially we're getting these routes over layer 3 VPN. Now, for whatever reason, we are then going to have maybe a DMVPN tunnel that's going to jump over this layer 3 VPN and maybe connect to router 2 and router 3 for whatever reason. I mean, there's multiple different scenarios where I've seen setups like this. Maybe there's an internet connection and they're going to light up a DMVPN interface. Let me pick a different line here. Maybe they're going to light up a DMVPN interface here, right? So that they can leverage both their layer 3 VPN as well as maybe a separate internet connection and be able to still get, a redundant connection. I would say maybe almost like a manual IWAN type of setup, right? But regardless, the point is that now I go ahead and I say, okay, I'm going to light up a DMVPN. That's what this is here. So let me write DMVPN. And I decide that I'm going to go ahead and use external BGP, where each one of these guys has a different autonomous system. So maybe this guy will be 65,001, maybe this guy will be 65,002, and this guy would just be 65,003. And, I get really, really, really lazy, and I go into my eBGP configuration and I say redistribute connected. Well, what did I just do? I just killed my DMVPN tunnel, because what I did was I ended up taking the very routes that I'm learning over EIGRP. I ended up taking those loopback addresses that I'm using to form my DMVPN tunnel, and I actually cranked them into BGP over the DMVPN. And so I'm going to start seeing link flapping. That's just one of the I would say the examples that I've seen, one of the hundreds of examples that I've seen where people forget their administrative distances and they go in and they do redistribution, or they do some type of configuration, DMVPN using multiple protocols or whatever, and they shoot themselves in the foot. So you have to remember some of these things. So let's just jot them down. So EIGRP is going to have 3 different I'm just going to list them here, and I'll do this in all the admin videos probably. So EIGRP has essentially 5 for a summary route. It has 90 for the D route, so I'll just put some here, summary, and I'll get into the EIGRP and the OSPF and all that in other videos. I just want to list them here. We have 170 for a DEX route, so if I have external EIGRP routes, I'm going to have 170. OSPF is going to have 110, regardless whether it's internal or external. We're going to have IS to IS, so let me write IS to IS. This guy has 115. I generally remember these because these are both my link state advertisement protocols, so these are generally easy to remember because they're only a 5 difference. And then we have IBGP, which is going to have an administrative distance of 200, and then eBGP, which is going to have an administrative distance of 20. And out of all of this, you don't care because you came to talk about RIP version 2, which is going to have an administrative distance of oh, now I'm having a brain fart. 120. What's really cool, by the way, NHRP, Next Hop Resolution Protocol, it's 250. So only the folks that actually watch this video are going to know that. Shh, don't tell anybody. Anyway, so RIP version 2 is going to have an administrative distance of 120. And when you're dealing with redistribution, when you're going in between some of these different protocols, you need to know what is going to have either a higher or lower administrative distance, not only to understand how the routes are going to be propagated, but also to control route preference. So for example, if I'm going to go ahead and send in, let's say, OSPF routes from router 3, and I'm going to have RIP routes from router 2, and both of them are advertising a route to this prefix, who is going to win? Well, router 3 is going to win because router 3 is going to have the administrative distance of 110, where RIP is going to have the administrative distance of 120. And the problem that I'm going to have here is that maybe my requirement, maybe in my network, I need to choose router 2 as my path preference, right? And so I'm going to need to understand how to tweak my administrative distance. So in this video, this is what I'm going to show you how to do. So let's just head over, let's configure a quick RIP configuration between router 1 and 2. Now we're already in there, so we'll say router RIP version 2, no auto, network 10.0.0.0, and redistribute connected. Copy this, go on to 2, crank that out. Let's say do show IP route RIP, and we have routes coming in from router 2, and this is good news. Let's actually, you know what? Let's actually also do this on router 3, just in case we decide to use it. Okay, bingo. All right, so what we want to do is we want to maybe again mess around with this prefix. Actually, let me just do, I think we may still have a few access lists hanging around here. So hang on, let's say show access list. And yes, we do. So we'll say config T, no access list 1, and do show access list, no access list 1. Let's check here. This is just left over from I believe, the filtering video. We'll recreate these anyway. So let's say do show IP route RIP. And let's mess around with this 1024.35 prefix again. Let's see if we can change the administrative distance. So we're going to go into our RIP process, and generally speaking, within all of the routing protocols, the way that we change the administrative distance is going to be with the distance command. And this, generally speaking, is going to be the way we do it both for protocols that are in IPv6 as well as IPv4. When you look at, OSPF version 3 still has the distance command. The syntax is a little bit different, but, if you know how to type distance with a question mark, you'll be able to get through it. So what I want to do is I want to essentially say that the administrative distance here, let's make it lower than OSPF. So let's make it 100. Let's assume here that we had OSPF coming in from one side. Actually, let's do that. So we'll say no router RIP. And we'll say router OSPF1, router ID 3.3.3, do show IP interface brief assigned. Let's say network 10.1.3. We'll say redistribute connected subnets, and we'll say Ethernet E01, IP OSPF network type point to point. Okay, ignore this, guys. What I'm just simply doing is I'm actually going to go ahead and router RIP. Let's say passive interface E01. All I'm doing at this point, guys, is I'm actually going to go ahead and I'm going to create an OSPF adjacency here. So let me just jot in what I'm doing. So I'm going to go ahead and actually put in what we originally said. So I'm going to say OSPF here. So these guys should come in with a distance of 110. And then I'm going to go ahead and run RIP here. And these guys should come in with an administrative distance of 120. Okay? So let's see what happens. So let's go over to 1. And let's say do show run section router RIP. That looks good. So let's say router OSPF1. We will say router ID 1.1.1, network 10.1.3.1, area 0, redistribute connected subnets, and I'm going to say interface E01, IP OSPF network type, point to point. Do show IP OSPF neighbor, So we have full neighborship. Let's say do show IP route OSPF, and we can see that we have OSPF routes that are coming in that we're learning. So now instead of doing a show IP route and picking a protocol, let's say show IP route, and let's actually take a look at our routing table. You can see we have a mix, right? So we have a mix of routes. We have these routes coming in as RIP on R1 coming in from router 2. These guys are coming in as OSPF routes. The problem is that I need to pick router 2 for this particular lab, if you will, and we need to do this using the distance command, because now unfortunately OSPF is taking precedence over RIP. So let's actually change this. So I'm going to say distance. Oop, got to go into RIP process, router RIP. Now I could also lower this in OSPF, but that's not what this lab is going to do. So we're going to say distance, and I need to pick the administrative distance essentially that I want to choose. So I'm going to say 100, and that's because I need this RIP route to have a lower administrative distance than what we're seeing in OSPF. Now the next thing it's going to want is the source IP address. In other words, who is this route actually coming from? And we're going to have to finish this up. Actually, let me hit the question mark here. We're going to have to finish this up with the wildcard bits, which in our case is going to be all zeros. Now, what I can also do is I can also attach an access list to this. And this is where it's important for you to actually work through all of these different combinations, because what I can do is maybe I don't want to change the administrative distance to all of these routes that are coming in. Maybe I simply want to do it to this one single route, and that is where an ACL comes into play. So I can go ahead and say 1, and now let's say do show run section RIP. You can see that now I'm going to go ahead and apply this distance command. I'm going to say, look, any route that's coming from this particular source that matches this ACL, I want you to change its administrative distance to 100. Thing is I need to create that ACL. So I'm going to say ACL 1 10.24.35.0/24. Oops, sorry, I forgot to permit. Do that all the time. Okay, and you can see that I don't have to use an ACL. I can use a standard named ACL if I want to. I don't have to use a numbered ACL. It's just sometimes this is more of a habit and it becomes easier. So let's say do clear IP route star, do show IP route, and let's see if we actually completed our task. And here we have it. So now you can see that we now have a RIP route coming in for 10.24.35, and the administrative distance is now 100. And it's very, very easy to do. So this isn't a very long video. Do show run section router RIP. It's not a very long video. All we're basically doing is we're changing the administrative distance. This is going to be the source, essentially the neighbor where the routes are coming from, followed by what routes we want to tweak. We don't have to do this though. I could say, let me just take this whole thing off. I could just say, look, change this for everything coming from that particular source, right? I could say distance 90 if I want to. I don't have to, I don't have to even enter the source. I can say, look, for every RIP route that I have, change it to 90. So suppose, my lab said, hey, either the lab that I was doing or the requirement for me or in my network, I had to choose RIP over any other protocol. I could just say distance 90, do show run section RIP. Let me remove all of these. And let's say do clear IP route star, and then say do show IP route, and let's just look at all this. If I say that, then you can say I've changed all the routes in RIP to 90. Okay. Now, of course, here I'm still going to get these routes in OSPF, which makes sense because there is nobody else that's actually advertising these routes other than router 3. So, of course, I'm going to choose that. But every other prefix, no matter what it is now taking the administrative distance of 90. So, not a hard thing to change, just something you got to put in the toolbox for when you need it.